Right, continue with the previous section. Let's take a look at another example where we want to find the limit of a function. So you will be familiar with this definition, this kind of definition where it's a piecewise function where fx is 2 when x smaller equals to 2 and x is actually 3 when x is greater than 2. Does the limit as x approaches 2 exist? So let's sketch the graph. The graph is not difficult to sketch. It's a horizontal line, y equals to 2, and then horizontal line, y equals to 3. Now, the question is, does the limit of fx as x approaches 2 exist? Now, if you can see, very quite obvious, as x tends closer and closer to 2 from the left, the limit is actually a 2. As x tends closer and closer to 2 from the right, the limit is not a 2, the limit is a 3. So therefore, it is quite obvious that it is 2 for the left limit, 3 for the right limit, and therefore since they are not the same, not equal, then the limit doesn't exist. And it's also quite safe to say that for such functions where it is not continuous, the limit as it approaches the value at its discontinuity point here, it doesn't exist. Alright, I hope that is a good example to contrast the earlier example. Therefore, it's not true that always the limit exists.